video I'll explain how to use bitwise operators for writing embedded C program. In embedded software development, configuring hardware registers is a common task. So we often need to configure different hardware registers of a microcontroller for developing software for embedded applications. Bitwise operations provide an efficient and precise meaning of setting, clearing, and toggling individual bits within these registers. So we can set, clear, or toggle individual bits without changing rest of the bits. So let's take a register DDRB. It's a register of Atmega 16 microcontroller, but the concept can also be applied to other microcontrollers as well. So it's a direction control register for port B, and it's an 8-bit register. The register is used to control direction of port B pins. So it's an 8-bit register, 0 bit number 0, bit number 1, 2, 3, 4, 5, 6, 7. Okay. So this bit 0 is corresponding to PB0 pin and this is corresponding to PB1 pin. So let's suppose that we want to configure PB0 in the output mode and PB1 in the input mode. So for that we have to make 1 here and we have to make 0 here, and we don't want to change rest of the pin configuration. So this is corresponding to PB2 and this is corresponding to PB7. So you don't want to change the value here, so let's write it X. So X could be 0 or X could be 1. Okay, so for that we can do OR and AND operation. So we can write here DDRB OR is equal to 1 left shifted by 0. And so here what we are doing OR operation of the content of DDRB with this number. So 0, 1, 2, 3, 4, 5, 6, 7, XX, and then we are doing OR operation with this number. Okay, so the result will be 1. Okay, now in the next step we have to make this bit 0. So after executing the OR operation, after the execution of this statement, the DDRB content will have this value. The 1 will come here, this will be X, X, and X. Now we have to make 0 here corresponding to PB1. So we will write the statement DDRB and is equal to not 1 left shifted by 1. Okay, so what we are doing AND operation with this number, with the content of DDRB. So at this point the content of DDRB XXX so this is the content of DDRB, and we are doing OR and AND operation with the number 1 1 1 1 1 1 0 and 1. So the result of AND operation will be X X 0 and 1. Okay, we can also write this is equivalent to this number. Okay, so 1 left shifted 1 is equal to 0 0 0 0 0 0 1 0, and when we write not, then this will become 1 1 1 1 1 1 0 1. Okay, so we can write here. So the first statement will be DDRB OR is equal to 1 left shifted by 0, and then next statement will be DDRB AND is equal to not 1 left shifted by 1. Okay, so using these two statements we can configure the ports in the respective modes. Okay, let's take one more example. So let's take same register DDRB, and here we want to make PB. So this bit number 0, bit number 1, bit number 2, bit number 3, 4, 5, 6 and 7, and this is corresponding to PB1, this is corresponding to PB0, PB1 and so on up to PB7. Now we want to make bit number We want to make PB1 in the output mode and PB2 also in the output mode, and PB3 in the input mode without changing configuration status of rest of the pins. Okay, so X here, X could be 0 or 1 based on the pin configuration. So now first we'll write ddrb or is equal to 3 left shifted by 1. Okay, so now this is equivalent to, so here we have 3, number 3. So number 3 is this one, 1 1 0 0 0, 8. So this is equivalent to 3. Now we are writing 3 left shifted by 1. So this one will come here, and this one will be replaced by 1, and this will be replaced by 0. Okay, so 3 left shifted by 1 is equivalent to 0 0 0 0 1 1 0. Okay, so now we are doing OR operation. So the content of ddrb will change to this value. 1 1 will come here, x x. So 0 1 2 3 4 5 6 7. Okay, now we want to make bit number 3 0. So we have to do AND operation. So we'll write ddrb and not equal to not 1 left shifted by 3. Okay, so 1 left shifted by 3 is equivalent to this number. 1 left shifted by 3 is equivalent to 0 0 0 0 0 1 0 0. This number, this is equivalent to 1 left shifted by 3. Okay, now not, if we take complement of this number, then this will become 1 1 1 1 0 1 1 1. So we have to do AND operation with this number. So this AND operation will give you the result 0 1 1 1. So the AND operation will give x x x, and then this will become 0, and this will remain 1 1, and then x. Okay, so final contents of ddrb will be x 1 1 0 x x x and x. Okay, so we have to do two operations. First we have to write ddrb or is equal to 3 left shifted by 1, and then we'll write ddrb and is equal to not 1 left shifted by 3.